In this video, I will be introducing the duration control analysis in PCSwim's graph panel. Unlike the single baseline comparator used for hydromodification, the duration control analysis requires two baseline conditions, which are used to define an acceptable operating range for a given time series. For example, streamflow downstream of an urbanized catchment. The full control condition represents the most desirable performance curve for bracketing the upper end of the operating range. This typically represents natural hydrology conditions or a pre-development runoff response. A scenario that matches this flow duration curve would be the ideal performance that offers 100% control to the desired objective. The maximum level of control is capped at 100%, so that occurrences of overcontrol do not exaggerate the overall benefits when calculating the average control level. The no control condition represents the least desirable performance curve for bracketing the lower end of the operating range. This typically represents existing hydrology conditions or a post-development runoff response without any stormwater management controls in place. A proposed scenario that matches this flow duration curve would offer 0% control to the desired objective. Proposed scenarios that perform worse than the no control curve can result in negative percent control values. In this example, we will be analyzing a bioretention cell that achieves the desired level of control over the flow range. The duration control analysis is typically applied to continuous simulation, and this graph shows model results for a 55-year simulation of 3 scenarios. The pre-development scenario will be the full control, and the allowable hydrology scenario, which was defined by the local regulatory agency and based on zoning, will be the no control. We will first enable the duration control analysis option and choose the appropriate scenarios for the full control and the no control conditions. We will then set our sampling range. It is important to ensure the sampling range values are set to include the full scope of results from all graph scenarios. The level of control is then calculated at each flow value based on the relative position of the scenario's flow duration curve between these two baseline performance curves. The average control level for the scenario is determined by averaging the control level for all plotted points on the flow duration curve and is displayed on the graph. The LID under controls at flow rates above 1.4 cubic feet per second. This is negative control since its performance falls below the lower allowable threshold. The LID over controls at flow rates below 0.8 cubic feet per second and is capped at 100% control since its performance goes above the upper natural threshold. Averaged across the entire flow range, the control level is 73%. If you would like to view the details, you can click on Show Report. For more information, please visit our support site at support.chiwater.com. Thanks for watching!